Hi everyone, this video is an exercise 11F question 1, and this exercise is about integration by parts. And integration by parts is another technique that is one of the most powerful techniques that we learn. And we normally use it as an alternative to the product rule that we have for differentiation, but it's sort of like the reverse of that. And we use integration by parts whenever we see the product of two functions that obviously the other methods cannot work, or they may be very challenging. So in this case, we have for the first part x sine x. And as you can see, these are the types of questions that you need to use integration by parts, because here we have x times e to the x, here is x times x squared x. So once you do a few, some different practice questions, then you'll see the pattern, and this will just come naturally to you that when you should use that. The only thing about integration by parts is just this formula that we need to memorize, especially the second part of that, which is u minus the integral of v minus du over dx times dx. So essentially, it just means that since we have two functions, we need to decide for which one to be equal to u and which one equal to basically dv by dx. And then from there, we'll continue. So I'm going to solve an example so you get an idea of what's going on. So in this video, I'm going to do part A. So we have root x, sorry, x times sine x dx. Okay. So as I said, we need to make two choices at the beginning. So first of all, just write down u du dx, v dv dx. Then you need to make two choices. So the first choice is what is equal to u, and the other choice is what is equal to dv by dx. Now, we normally want to set the easier function, the simpler looking one, equal to u, and the one that may be a bit more complicated, equal to dv by dx. The reason for that is we usually want the easier one to be equal to u, because when we differentiate that, then the derivative is actually something that is even simpler. So in this case, when you differentiate x, you'll simply get just 1, right? So that's the point of that. Because remember, in the formula, inside the integral, you will substitute du by dx, not u. So that's why we want du by dx to be very easy, so that it makes integration easier. We don't want to get something more complicated, so that the integration becomes harder. And same thing also applies here to some extent, because we also want to, because again, this time we substitute v into the formula, not dv by dx. So we kind of want to set something equal to dv by dx such that when we integrate that, then the integral isn't too bad, because that's going to be substituted into the formula. So now then, integral of sine x is simply minus cos x, so it's not too bad. Now, we use a formula. So the formula says first u times v. So u times v in our case is x times minus cos x, which is just minus x cos x outside of the integral, and then minus inside the integral we have v times du by dx. So du by dx is simply equal to 1, and then v is minus cos x. So at this point, we basically have everything, right? So, and we simplify this, so we get minus x cos x outside. I mean, this doesn't simplify, but here we can take this negative outside of the integral, so it becomes positive, and then just cos x dx. And now minus x cos x outside, so cos x integrates to sine x plus c, and that's it.